So hi, I'm Jeremy Gebman. I work at Linergy. I work on validation layers, mostly on performance. And today we're going to talk about some tips about how to use validation in Vulkan. This isn't an exhaustive tutorial. I don't think there's time in the whole conference for that. But it's hopefully got some things that are useful. Some of it will be reviewed to some of you, and then some status about where we're at and what kind of challenges we have working on validation. So start off, what is validation? So basically it's a shared library that can be attached to your Vulkan program that adds all of the error checking that is defined in the spec. The reason it is done this way comes out of OpenGL. There was a lot of errors in OpenGL drivers that were required to be implemented by every vendor. And some of those took CPU time, reduced performance. And when Vulkan was being designed, the decision was made to put all the validation in this code that can be plugged in at runtime and pulled out when you're in production application, because the user doesn't need to debug your working program. And so Vulkan has what's called the loader layer interface, which allows arbitrary shared libraries to be injected in between your Vulkan function calls, and they get intercepted. And this layer can be validation and choose to check your parameters for error messages, or it could be capturing all your API calls and printing them out, or it could be some other tool that wasn't designed yet. So the types of errors that we look at in validation, I like to think of as mostly these three types. So you have the incorrect usage of the API, where you have a bad parameter, like mem copy. If you copied a null, you're going to crash. So validation is really good at handling errors like this. Then there's runtime errors, which are malloking too much memory, using too many resources. That's going to vary depending on what else is going on in the system and the state of the computer. So in some cases, validation can help with these. In others, it can't. Usually, if you see a function that returns a VK result, that means there's a chance of a runtime error. You should handle those errors somehow. And then the last case is using the API suboptimally. So with malloc or calloc, you can allocate a 0-byte chunk of memory, and it's implementation defined. What happens with that? It'll work. You might get a null. You might get a pointer that points to nothing. But if you have a pointer that points to nothing, why bother doing that? And we have a section of validation called best practices that's for checks like that. So the quick way to get started with validation, if you're not used to it, is get the SDK. There's also packages, especially on Linux, there's packages that contain all of the SDK components that you can install. And run vkconfig, the Vulkan Configurator. There's also ways to enable validation with environment variables or programmatically when you're creating your instance by adding a layer to the list of instance layers. With vkconfig, you just need to set 3 settings to get started: override layers and enable validation, and use the standard preset. And we'll talk a bit more about what some of these things mean going forward. But this will enable validation. You'll start getting messages out, and hopefully your program is correct and you won't get very many. And to kind of illustrate how this works, I took vkcube and I added an error where I made the size of a buffer copy be too big by changing this one parameter. And that causes a visual artifact where the cube doesn't look right anymore, and we want to fix it. So validation finds this, gives us a huge error message. Part of it says exactly what happened, which is this region has a size that's bigger than the size of the whole buffer. So that's not going to work. Part of it has a valid usage ID. And this is a really important part of both the spec and validation, which is there's these VUID text and then a number. Those are all unique identifiers in the specification that tell you exactly what part of the spec you violated. And you can get, you can Google that usually and end up on a man page that'll show you what's wrong. You can look in the validation code for it, or you can look in the spec for it. There's also some categories of errors that are not VUIDs and are not in the spec. Some of those are things that validation engineers found that aren't yet in the spec. Some of them are the best practices, which are also not in the spec. And then some of them are related to synchronization validation, which all the synchronization rules are in the spec, but there's not specific valid usages for every single one of them. And then we have the object handles of the objects involved in the error. So you have a buffer and a command buffer, and not much information at this stage about them other than what those handles are. And then we do include the text of the spec you violated and a link that will take you straight to where that error occurred so that you can go look up more information. So the general approach to fixing all these errors is a lot like compiler errors. You want to start with the first error and fix it because you can get situations where you have a cascade of follow-on errors based on one simple problem. So always start with the first one. And you can also use the debugger and using this break debug action, which is a configuration option I'll show you how to enable. That'll stop you right where the error is detected. Usually that's within the call where you introduce the error, and you can see the whole stack trace and look at your program and try and figure out what happened. Like I mentioned already, if you're confused, another good option is to look at the validation source code on GitHub. And a lot of times that'll either give you a clue as to what you're doing wrong, or you can see what we're checking. That might help, or you might spot a problem in how we're validating and be able to help us fix it. And then the last thing is, if you have a pretty complicated program, there's the way to add names to all your objects into sections like command buffers, which we'll go over in a minute. And that can really help you isolate what's going wrong or where the problem is happening. So configuration options, they're really complicated. I've added links to a bunch of documentation about how to do this. There will be a QR code at the end if you want to grab the presentation immediately. It should be pretty easy. Again, vkconfig is the easiest way to configure validation. There's also a configuration file, which vkconfig writes. There's an extension that lets you set all this in your own code. You can have your own debug options. And then there's environment variables, which are super convenient, but aren't fully covering all the configuration options. So one of the big concepts we have in vkconfig is validation areas. And so these are parts of validation that you can turn on and off. And this is done mostly to manage performance, where if you enable everything, it's too slow. And you want to be able to focus in on certain parts of validation. Stateless is very simple checks that don't require us keeping track of anything beyond the current function call. So that memcopy example I had where there's a null pointer, that'd be a stateless check. Core validation is almost everything else. That's what you want to spend most of your time running. It's fairly expensive compared to stateless, so it does add overhead to your application. Thread safety is all about making sure that you follow Vulkan's external synchronization guidelines. You're only allowed to use objects from one thread at a time. It's up to you to have locking or mutexes or division of labor on your threads to prevent that from happening. The thread safety area will catch that. Handle wrapping is about making sure you don't reuse stale handles. Drivers can reuse handles or even have non-unique handles for multiple create calls. And this feature will make sure those handles are unique and make sure you're not reusing anything. It also makes the handles deterministic, so you can run the same program and get the same handles every time, which is sometimes useful for debugging. Object lifetime is, again, about making sure that you don't use handles after they've been destroyed. The more interesting parts of validation are GPU assisted. So there's GPU AV, which is instrumentation of SPIR-V code to try and catch errors with descriptors or with buffer device addresses. And then there's debug printf, which lets you add printf statements to your own shader code. Synchronization validation, again, it covers all of the synchronization rules, and for pipeline barriers and pipeline stages, access masks, events, all that stuff. We've done a presentation about it at Vulkanised in the past. I'd advise you to go look up that presentation if you want to learn more about it. And then best practices is, again, the performance warnings. And let's see. So the easiest way to do this is to use these standard presets. There's presets for every validation area in vkconfig, and that'll be one button you push that gets you into a configuration that we test that we think is a good idea to run. That's the easiest way to change between all of these different validation areas. You can also use the configuration yourself with the other options. And again, don't enable these big four areas at the same time, because it adds quite a bit of overhead and it'll slow your program down more than you really want. And usually we recommend that when you're using these other areas, that you bounce back to core after you fix something to make sure you haven't added a problem. Like, for example, you got a pipeline barrier, but you get one of the parameters wrong that you found from synchronization validation. Run it through core, make sure everything else is okay, and then keep working on synchronization. Break on error. This is a pretty easy one. It's just another option in vkconfig or in the config file. Repeated messages. So one of the big problems people have is that if you have an error that's in every command buffer or every frame, you'll just get flooded with error messages. So we have an option to limit how many instances of each identical VUID you get before we start suppressing them. We also have an option to allow you to turn off specific VUIDs if you're sick of hearing about them, if it's a false positive or not related to the problem you're trying to solve at the current moment. So we hear sometimes that people aren't aware of this feature. It really does help make it easier to wade through all the areas you get. And now we're going to talk about the Debug Utilities extension. So this is an extension that's implemented by the validation layer. I think it's also implemented by some of the drivers, and it lets you define your own error callback and attach names to Vulkan objects and command buffer sequences and queue submissions. And it's used by quite a few tools. I see it in a lot of test frameworks. I see it in RenderDoc. vkcube even shows you how to make your own error message. So object naming is pretty easy. There's a function you call with your Vulkan handle, and you can attach any name. You'll see down in the bottom right that I've added names to my objects from the error messages. So one of them is a command buffer for pairing all of my memory, and another one is a texture for uploading, a texture buffer for uploading one of the images used by vkcube. And then command buffer labels are a little bit different because they're like a stack. So you can have as many labels, well, you can have multiple labels attached to a command buffer at a time, and you can push new labels on and pop them out. So in this example, the most recent label is the inner one. So it's a staging buffer copy, and that happens to be where I added the error. And then that's inside of a function that is uploading that texture, and then that's inside of another function that's doing all the preparation for drawing the cube. And again, as I mentioned, you can have your own callback. You get all the information. This is the same mechanism we use in the default callback. So you get all the information we get. You can make your own message format because it is a pretty complicated format, and you might be able to come up with something you like better. You can add the messages straight into your logging stream so that you get your own application logging messages and the validation errors interleaved in the correct order so that you can kind of figure out where you're at. You can send some of your messages to a UI. RenderDoc does this. They have a tab that you can pull up that shows you all the validation error messages for the frame you're rendering. You could trigger unit test failures. And one thing we see that I don't recommend is filtering out unwanted messages. This is going to be doing it in this callback is going to be much slower than using the options I talked about earlier, because we filter out before we do all of the text generation to make that massive message. And this happens after you have the whole message built. So it's going to be much slower. So then going back to vkcube, we have the code that was the error. I've added functions that push on a command buffer label and then pop it off after this one copy command. and that changes the error message so that I have the all the object names attached to the objects involved in the error, and I also have my labels so I can go look at the code and find what I was doing and which texture it was. So there's quite a bit going on in validation, and currently there's over 14,000 unique VUIDs that are in the spec, and I'll show you just how close we get to implementing them all. Quite often, it's harder to actually write validation than it is to implement the feature in the driver, because the point of Vulkan is not making the hardware do extra work. So the hardware is not looking at it if your descriptor is valid or not, and we have to do that in software, or in instrumented SPIR-V. So that takes quite a bit of work. Vendor extensions that's kind of up to the vendor on how much code they provide us to validate each extension, and it varies quite a bit. Sometimes it's none, and sometimes it's pretty close to complete. So the way we deal with this is, it's triage. When new extensions are made, we really try to work with the authors. We want to get as close to 100% validation as we can for each extension when it goes into our code base. That's the best time to add validation, because it's fresh in everybody's mind and it's just there and it's done. And otherwise, somebody will have to come back later and figure it out. We do take incomplete issues on GitHub very seriously. We try to prioritize VUIDs that people want to be validated if they're not. So please, if you have a problem with validation, file an issue. That's a good way to get our attention, and we do take them seriously. So this is the history of valid usage for all of Vulkan, or pretty close to all of Vulkan. The yellow line is the total number of VUIDs in the spec. The green line is what is implemented in validation, and the blue line is the gap. So since beginning of September, we've added more VUIDs to the spec than were in Vulkan 1.0 when they first started doing VUIDs, which was, I think, shortly after 1.0. So 3,000 plus VUIDs in the last 5 months. And this kind of shows a breakdown of where the valid usage comes from. So quite a bit comes from the core, which is 1.0. 1.3 added quite a few, and then ray tracing and mesh shader added quite a few. You can see that the amount that we're implementing varies quite a bit based on the extension. That just, like I said, it's largely determined by what gets implemented when the extension gets added. So that it's really important to work with us on adding validation for when you're writing an extension. Some VUIDs are hard to check, and yesterday there was quite a bit of talk about bindless, and this is one part of validation where we have quite a bit of trouble, and it's because of language in the spec about only dynamically used descriptors need to be valid. So only descriptors that are actually used by the shader are required to be valid when you're using bindless features. And it's quite common for a bindless application to have 1 million descriptors in their descriptor set at a time, but only use 10 or 100 of them in a given shader or draw call. So we don't know which of those shaders need to be valid right now. And we have either we check them all in some cases, and that's extremely slow because it's 1 million versus 100, or we skip validation, and then you don't get coverage for those possible errors. And really what needs to happen is we need to improve GQAV to have more instrumentation to tell us which descriptors got used, and only then we can limit validation to what actually is required to be valid. Recently, or last year, we've taken, like I said, quite a bit of work has gone into new extensions, and I really would like to say thank you to all the extension authors who worked with us on validation. We did get pretty good coverage for these most recent big extensions. Synchronization validation phase 2 got implemented. That expanded the coverage from a single command buffer to multi-command buffers, execute commands, and multi-queue checks. SPIR-V runtime validation has been improved quite a bit. Performance for multi-threaded applications has been improved, and GQAV performance has been improved. We're also working to add more of those unassigned errors back to the spec, and we upgraded from C++11 to 17. We're working a lot on the code quality validation to make it easier for people to understand what's going on and to contribute, and also to understand errors when they're trying to debug something. Upcoming, personally, my biggest priority is working on that descriptor indexing problem, both for performance and, like I said, to close gaps. We do need to work on timeline semaphores, and there's execution time to VUIDs. It's a very similar problem where we don't know what's going to execute until right when it does. So we have some validation gaps there. Shader validation is improvements are required. And again, if you see something that you'd like us to do better, please file an issue. And we do also take pull requests, and we really appreciate pull requests, honestly. And that's it. So any questions? Yeah. So the question is, how does how does this validation work? Do we remember the last few submitted commands?
Yeah, because it used to only validate within one single segment. So the previous submit was validated in terms of.
Yeah.
But now
yeah. So the question's about synchronization validation phase 2, and we were only validating with one submit, and now it's keeping track of state for each queue, and it's keeping track of the command buffers that haven't completed execution, and trying to summarize the state to allow you to check between queues, and then looking at where you have semaphores synchronizing between queues, and trying to import state from one side to the other. It's quite complicated. Yeah.
I guess the validation layer just keeps track of that state.
Yeah, and it is quite expensive, and there's quite a bit of memory. There is a design document about synchronization validation. I'm fairly certain it's been updated to talk about phase 2. That's on GitHub in the docs folder. That'd be the best place to look, and then either hit me up on Slack or GitHub, or John Zuloff is the author of that, and he'd probably be the best person to answer. Yes.
I've had a little bit of a problem trying to get validation layers, swap chain, and switch chain to work together. That's all.
We are running with Swift Shader. I'm not sure about swap chain. He's had trouble with getting validation layers to work with swap chains and Swift Shader.
Yes.
And we do have people that have been using Swift Shader for testing. I don't know if they've tried swap chains. This would be a perfect thing to file an issue describing your problem. We can see if we can get you some help. Thanks. Any other questions? Yes. So the question is, you're implementing a library to do virtual memory allocation, and you want to integrate that with validation layers. You could, so there might be, I mean, it's unclear to me if you want to leave that up to your user base to add validation, and you want to produce your own error messages. The Debug Utils extension might provide you that. Mark does it. Yeah, Mark Young is the author of the Debug Utils extension. He says there is a way to add your own errors. I think it's possible. The devil would be in the details, and maybe come talk to us after. That might be good. Anything else?